All right, welcome back to The Explainer. Today we're diving into a huge question, maybe the biggest question in AI right now. When you see a large language model do something incredible, is it actually thinking? Or is it all just an illusion? I mean, come on, you've probably been there, right? You ask an AI something, and the answer it gives you is just mind-blowing. It feels like pure magic. It can spit out poetry, it can debug your code, it can even explain quantum physics. But that big question just hangs in the air. Is it really reasoning its way to that answer, or is it just the world's best mimic? Okay, so let's get right into it. Take a look at this. We've got an LLM solving a pretty basic math problem. But notice, it doesn't just spit out the number, it shows its work, right? Step by step, just like your old math teacher made you do. This is a specific technique called chain of thought, and it's designed to make the AI look like it's thinking. But the key word there is look. So to figure out what's really going on, we need to pull back the curtain. Let's move past the performance and dig into what might be the most important distinction here. The difference between just matching patterns and, well, actual genuine thinking. You see, at their absolute core, LLMs are prediction machines. The best way to think about it, it's like a superpowered autocomplete, on your phone or email, but on a cosmic scale. It's been trained on just an insane amount of text from the internet, from books, from code, and all of that training has made it incredibly, incredibly good at one single thing, guessing the most likely next word in a sentence. And that right there, that's the heart of the whole debate. On one hand, you have the idea that AI is just a brilliant pattern matcher. It's not understanding, it's just finding correlations in the data to simulate reasoning. But on the other hand, is it possible it's doing something more, something genuine? Actually applying logic, understanding cause and effect, thinking in the abstract? Well, right now, the expert consensus seems to be landing pretty heavily on one side of that debate. The research is pretty clear. The fundamental architecture of these models is built to simulate reasoning, not to actually do it. I love this analogy. It's like a phenomenal actor who memorizes a physicist's lines. They can deliver them perfectly, they sound brilliant, but they have absolutely no idea what the equations actually mean. Okay, so if it is just a simulation, how good is that simulation? Well, to find out, researchers have basically created what you could call a reasoning gauntlet. It's this whole series of really tough tests designed specifically to push these AIs to their absolute limits and see where they break. And the results? Honestly, they can be pretty sobering. Get this. On the absolute hardest formal logic tasks, the best models out there are only performing about 13.6% better than pure chance. Just random guessing. That really puts into perspective how big the gap still is. And it's not just an isolated thing. You see this across the board. When you look at benchmarks designed to be like those brutal logic puzzles on the GMAT or the LSAT, even the top-tier models like GPT-4 are barely scraping by with a passing grade, if they pass at all. It really suggests they're leaning on familiar phrasing they've seen before, not on a deep, flexible understanding of logic.
But here's where it gets really interesting. Kind of weird, actually. In the ways they fail, these AIs can be shockingly human. They show something called belief bias. What that means is they're way more likely to agree with a conclusion if it sounds believable, if it fits the patterns in their data, even if the logic getting there is totally wrong. Sound like anyone you know? Yeah, we humans do that all the time.
Now, when we talk about understanding cause and effect, this is where the illusion really starts to crack. On problems that look familiar, stuff it's seen in its training data, an LLM can look like a total genius, scoring 85%, no problem. But the second you throw it a curveball, a new adversarial problem designed to trick pattern matching, performance just collapses. It falls off a cliff. For many researchers, this is the smoking gun. It shows they don't really get causality. And this brings us right to the heart of the matter. A major study from Apple, which they couldn't have named more perfectly, they called it the illusion of thinking. It found that once you make a problem complex enough, beyond a certain threshold, the performance of all current models just falls apart. The simulation breaks. It can't keep up. Okay, but it's not all bad news. The story definitely doesn't end there, because researchers aren't just pointing out the flaws. They're actively building what you could call an upgrade pack. A whole suite of really clever techniques designed to push these models beyond simulation and teach them how to actually reason. And it really starts with that simple but kind of revolutionary idea we saw at the very beginning, chain of thought. It sounds basic, right? Just telling the model to think step by step. But by forcing it to write out its reasoning process, you see a huge jump in accuracy, especially for problems that have multiple steps. But what happens if that first step is wrong? With chain of thought, you're stuck going down a bad path. That's why the next big evolution is called tree of thoughts. Instead of one linear path, this technique lets the AI explore multiple different lines of reasoning at the same time. Think of it like a mind map of different possibilities.
So here's how it works. The model brainstorms a few different ways to start the problem. It then looks at each one and asks, is this going anywhere? It gets rid of the unpromising paths. It prunes the dead branches of the tree and focuses on the ones that look good. The most important part? It lets the model backtrack if it makes a mistake. That is a huge step towards more flexible, human-like thinking.
And the toolbox is getting bigger all the time. On top of that, researchers are using things like reinforcement learning, which basically gives the AI a little reward for each correct step in its reasoning. And there's also something called test time scaling, which is a clever way to give the model more computing power, but only when it runs into a really tough problem.
And this isn't just theory. It's getting real results. A great example is IBM's Granite model. By using this smart scaling technique, it can actually outperform models that are way, way bigger on really hard competition-level math problems. It's the perfect proof that the future isn't just about building bigger models, it's about building smarter ones.
So when you put all this together, where are we headed? What does the future of machine minds actually look like?
Well, the most exciting paths forward seem to be about combining all these powerful new tools. We're talking about using advanced search methods like tree of thoughts, fine-tuning behavior with reinforcement learning, and maybe the biggest one of all, creating hybrid models that combine the pattern-matching genius of LLMs with the strict, reliable rules of formal logic.
And that really seems to be the consensus growing in the field. The future isn't just more data and bigger models. It's about building smarter hybrid systems that give us the best of both worlds. You get the incredible, almost intuitive pattern matching of a neural network, combined with the rock-solid, verifiable logic of a traditional reasoning engine.
So, in a way, we're right back where we started. Today's LLMs are becoming absolute masters of simulation. Their ability to look like they're thinking is nothing short of extraordinary. But that final leap, the journey to genuine, flexible, human-level reasoning, well, that journey is still far from over.
And that leaves us with a final, pretty deep question to think about. If we keep going down this path, and we eventually build a machine whose reasoning is so perfect that you literally cannot tell it apart from a human's, does it still matter how it gets there? If the simulation is perfect, is it still an illusion? Something to chew on. Thanks for joining The Explainer.